Hey there. Let's get some more work done. But first, as always, I gotta get some music going. And also I got myself an energy drink so I don't literally fall asleep. That made me a bit too cozy. Yeah, that's too chill. Ooh, maybe the Hades soundtrack. What other cool soundtracks are there? Blasphemous. It's also a good one, I think. Let's see. The Doom Eternal soundtrack. It might be a little bit too much, actually. I have an idea. How about this one? Oh god, that's disgusting. Jesus Christ. Can I just assume that if it's on YouTube it's safe to play? Of course not if they have a license, but I mean, highly doubt that. I like this one. Let's listen to a bit of chiptune. Okay. Okay, maybe this is too much. Oh god, Jesus Christ. Sorry. Yeah, that's much better. Okay. So last time, the problem was that the ACX needs to contain string length, and as you can see I've since fixed this issue, and ACX contains string length now. That's the only thing I've done off stream, just this one line. Okay, so now we do have a load library. No, we don't, because I'm gonna start the driver and I'm gonna show you where we are. At this point we should have, yes, we have the address of load library, not the address, we have the index in the name pointer table to the load library string, yes, in ABP. So it's 3C5, which is actually still very easily inside of 16-bit range. The reason I'm wondering is we're using a 16-bit register here, which we need to do because this value here, the ordinal, is a 16-byte value. Bit, I mean. That would be huge. Okay, EDX is... what is EDX? Let's see. ADX. Address of name ordinals. So this is the ordinal table, which is what we want. As you can see, we look up function index in ordinal table. Here the ordinal is in R10 and the index in rex. Oh, I keep doing this. This is ridiculous. So, of course, instead of doing +2, I need to do ×2. The instruction I fucked up is here. 8B 2C6A 2C6A. Okay, stop the driver. Build and start the driver once more. Okay, so in BP we now have the ordinal. Yeah, that looks reasonable. And now, what the fuck is this? Excuse me? What am I doing? What is that instruction? Get ordinal into BP. Oh. Oopsie daisy. Yeah, this is not part of the instruction. No, wait, I need to stop it first before we can build and start it. So, how are we looking now? The instruction is looking a little bit more realistic now. EBP, EBP, EBP. Oh, right, I forgot something. I forgot to add ABP EAX to make it a virtual address. Hey, there we go. As you can see, EBP points to load library A. Follow in disassembly. Yes, this is a jump pad thing. And of course we need to copy this instruction and add it. Library A VA. Bytes target 3 E8 okay, so now we have to call load library, but first one more thing we need to think about, and that is stack alignment. The stack needs to be 16-bit aligned, but I don't remember if that's before pushing the arguments or after. The stack looks like this on entry to main. Okay. Okay. Wait, what? Well, that's certainly an easy way to do it. But how do we undo this? Or do we just push the stack pointer? Guess we could do that. But that still doesn't answer my question. here we go, before making the call. I mean, obviously before making the call, but oh, here we go. Place all of the arguments in position. Why are they all using AT&T syntax? That is disgusting. That is also not what I need to know. Shut up. I think it's before pushing the arguments, but I need to be sure. No. Yeah, I can't do that because we don't want to change anything on the stack or ESP itself. Push the arguments before a function call. Remember that changes the ESP. Simplify by preserving. Huh. Yeah, but that doesn't help me with calling stuff. When we align the stack, if you're not sure why this is happening, calling standard to 16-byte boundary. Try to figure out how much ESP has changed. Yes, yes. Okay. Amazing insight. I feel very much enlightened. That sounds like a birthday song. Here we go. This is the answer I need. ASP plus 4 is 16 byte aligned on entry to a function, i.e. ESP must be 16-bit aligned before a call instruction, so args on the stack at a 16 byte start at a 16-byte boundary. New processes start with ESP aligned. ESP points to argc, not the return address. Wait, does that mean we are already aligned? Hold up. So we answered the entry point now. Is the stack aligned? Yes. Okay. So what this means is we need to load library A. Okay, it's a single argument, which means pushing this argument will misalign the stack. So we are pushing the argument, and we should also push 3 more things. So the stack is then aligned once again. Yes, because it has to be aligned before the call instruction, so when the return address is pushed, it's misaligned again. Shit, which one was the... This is the one I was reading. I think this means we need to. Oh god. Do we need to first increase the stack by 3 times 8, then push our argument and then call, or do we push the argument then align it? No, I think the alignment comes first. Let's get to this part. Why do I do this? Oh, I also need to take into consideration the registers I'm saving. Of course. So we are saving EAX, ECX, EDX, but we also need to save a couple more. Push ABX, push ABP, push ESI, push EDI. Yeah, that's it. I mean, that's pretty much all of them. Oops. Here we go. EAX, right, and then we do ABX. Oh no, 53. Wait, why is that out of order? Why does ACX come after EAX? Anyway, weird. So how many are we pushing? 1, 2, 3, 4, 5, 6, 7. Stack is aligned. Pushing 7 things means what is 16 divided by 4? That is 4. So we are barely misaligned, which is perfect because pushing the argument aligns us completely, and I don't even need to do anything in about the alignment. Okay, so where do we put the VA? Like, that would have been a very useful comment. Oh god. Gotta do something weird here. Can I just edit multiple bytes? Ah, whatever. Oh, I got something for my allergies. Hell yeah. Take them drugs. I'm just gonna start the driver and then we can see. It's already running. Okay, well. ABP. Yes. ABP will have the address, so what we need to do afterwards is push that beef, which will be the address of the string, the DLL file we want to load, and of course we need to actually call it ABP, and that's it. Push DLL path. Oops. Right, bytes. Now we need to get the actual value. Not bytes, right? Type uint32, and of course into target. What's the name? Fuck. Module file. Yes. To syswow. No, to wow. Yes. Because we need to convert it to a 32-bit address, specifically to a uint32. Stack is already aligned. That's very important, by the way. Do not forget to 16-byte align your stack. And in case I've been mistaken, we will in a moment check if the stack is actually aligned the way it should be. Okay, looks good so far. And we are pushing. Yes, we have successfully pushed the address of the file, and we are calling, and let's see if we get a segmentation fault. Shit. No, wait, that's just a breakpoint. Oh fuck, it worked. We are inside the DLL main, and it's saying ALML, which is beautiful. Thank you very much. It's stopping because I put a breakpoint there inside the code itself. I know it's tripping because it cannot deal with that, I guess. It's weird. Just very weird. Here we go. Everything worked out. Now we need to do proper cleanup. So, what does proper cleanup mean? First we pop the registers in reverse order. Actually, before we do that, I think I want to make a new DLL file. No, I'm not going to, but I will. Actually, no. I'm gonna do cleanup first, and then we are going to do some more checking if everything's working fine. So, we are popping now in reverse order. EDI, ASI, ABP, ADX, pop ADX, ACX, wait, didn't we just do EBX? No, we didn't. EAX. And then I'm copying those. Oh, there we are. Oops. This is not the instruction I was looking for. 5e pop ESI um 5d I said. And pop EDI. No. Wait. Why is... Oh yeah, ADI, ESI, and then EBP. Hmm, 5A. Pop ADX. Uh, 5.9 gonna be pop ECX. Oh wait, I've done this before. But I forgot EBX. (5B) EBX. Here we go. So we have ADI, ASI, ABP, ADX, ACX, ABX, EAX, yes. Exactly. Let's see how that looks. Okay, stack is not aligned. Fuck. Why are you not aligned? Gonna put a breakpoint up here. Wait, why are we not pushing? 1, 2, 3, 4, 5. 2, 3, 4, 5, 6, 7. Where did the other pushes go? One, two, three, four. 1, 2, 3, 4, 5, 6, 7. Okay, never mind. It was just because of the data we had above. It got interpreted and mixed with these instructions. Oh damn, you, music is over. Need new music. Let's try some synth wave. Yes. So we enter the thing aligned and we push a couple things and then we are misaligned in a very different way than I anticipated. So we start at 0, we go to 4, 8, 0, 4, 8, 0, 4. Oh, of course. 1, 2, 3, 4. 4 of them. No, I don't understand. Am I miscounting? 4 of them are 16 byte. Let me just quickly do this again. So if we execute 4 pushes, 1, 2, 3, 1, 2, 3, 4. Now we have executed 4 of them. Oh, I thought we would be aligned. Excuse me. Why are we not? Okay, 1. How do we get to 8 with the 1 push? Am I stupid? Wait, now it's not aligned. Or is it? Am I missing something? Oh wait, there was a trick to bring up a calculator. How do I do that? The developer of x86 DBT told me that there was some way to get a calculator in here. Question mark. Oh, here we go. Nope, we need an actual calculator. Yeah, this is not aligned. Wait. Programmer, hex. No, wait, not hex. Yo, there's a firehawk in my chat. Yeah, it actually is not aligned. Oh, we have a return address. That is very interesting. Does that mean we are 4 bytes off? What if I add 4 to this? Plus 4. Okay, then it's aligned. I see now. So it might just be the return address that is misaligning us, but we need to make sure that this is consistent. So I'm just gonna run it a few times. Wait, now we actually have different alignment. Fuck! 38. Well, 38 means that we need to add another 8 bytes to be aligned. Now we add a 4, which means we need 3 bytes to be aligned. Again. 2 bytes again. 2 bytes. 2 values. 3, 2. 2, no, 3. 0. Fuck. This is actually just 100% inconsistent. Great. I'm amazed. Why? Didn't it say that it's guaranteed that we get an aligned stack on the entry point? Didn't this person literally say that? Guarantees that new 32-bit processes start with ESP aligned on a 16-byte boundary. Oh, on ELF. Yeah, amazing. This does not count for Windows, I assume. What do Windows compilers do? Do they just go cry? Like, just in general, you know? Just be sad. So we are calling this function, and yep, it is specifically aligning the stack. In a very weird way. An extremely weird way. That's not the stack pointer I'm looking at, which also explains why it's so weird. Fuck. Never mind. So, let's just highlight the stack pointer. Here we go. Add C. What? And here we just return. So we jump over here and we call this, and get system time as file time. Oh, wait, this is not actually called. What is the initialization of a notepad doing? Just gonna go in there and wait. Oh fuck, I just jumped over. Whatever. ESP is not aligned. Perfect. That's what I wanted to see. So jump into push 14. ESP is still not aligned. Push something else. Now it's aligned. And now we call something coincidentally. Is that just true on every run? Hold up. How does it know? Okay, now it's different. Let's see if it's still... Okay, now it's not aligned before the call, which is what I wanted to see. Highlight ESP again so I don't miss any obvious tampering. Excuse me, what the fuck? What? Your funny words, Magic Man. Yeah, so currently I'm trying to figure out how to align the stack because, well, just to give you the TLDR, when you call a function in Windows, in most calling conventions, the function expects the stack pointer, ESP, to be divisible by 16. So there needs to be a 0 at the end of this number here. And as you can see, there's no 0. And the weird thing is that every time I run the program, there's another thing at the end of this. So it's not consistent. But I need it to be divisible by 16 before I call anything, because that's what Windows API functions and pretty much every function expect. Shut up. Run it until it's 0. Yeah, just let all the processes crash that happen to not be 0. That looks like a very stable kernel driver. 50% chance of a blue screen of death. Acceptable. Just restart the computer until it works. What are they doing? They're putting a value on from the stack into EAX, then they replace it by ABP, put something into EBP, subtract ESP by this value from the stack, and now it is still not aligned. It's just weird. Now it's aligned. What just happened? What just happened? Windows is doing weird things. Okay, not Windows, it's, I mean, the compiler, but like still, what the fuck? Windows x86 asm align stack. What if I just ended by 0? No, not 0. Let me think. If I make the last digit go 0, so the last 4 bytes, that means we are decreasing the value, we are truncating it. And decreasing a value on the stack means, is it growing or shrinking? Always forgot. It is growing. Stack goes up. So, I mean, we could just end the stack pointer and push it beforehand so it's unmodified. Guess that's an option. What if it's already 0? Then that's also not a problem. Okay. Yeah, I think that might work. But still, I'm just gonna quickly check if there's a better way. Everything is about 64-bit. It's hard to find resources for 32-bit. That's not the kind of alignment I care about. Oh, Firehawk, did you actually get away with not aligning your stack when you wrote your shellcode? That's actually kind of lucky. So either you accidentally only had to make yeah, shadow stack. Yeah, calling convention also says it needs to be 16-bit aligned though. You probably, I mean, you either had it aligned by accident, or the more likely option is the APIs that you called did not try to use what's it called? MMX instructions, there's a specific instruction set that crashes when the stack is not 16-bit aligned. 16-byte, I mean. So when you don't align your stack, there's the possibility that some APIs just crash your program. Yeah, that's amazing. Wait, Windows functions don't have such restrictions and align stack only to 4 bytes. Whoa, 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 whoa. On 32-bit, it doesn't need to be aligned. I mean, that's what this person is saying, at least. I know that it has to be for 64-byte bit. No. Wait, yes. But Windows functions don't have such restrictions. Call a Windows function, it calls a callback, this callback function, misaligned stack function. Oh. Huh. 2018. That's not too long ago. Shit, I might not actually need to align it, which would just be wonderful. Is the driver running? No, it's not. So let's run it again. And I mean, until something crashes, we just don't care about the alignment. But what I do care about is... I'm just gonna make a screenshot of this. Open it up on my second screen, and I'm gonna check if everything, all the registers and so on, stay the same after we ran our code. We need to patch this once again. Or the debugger gets confused. So EAX, correct EBX, correct ACX, correct ADX, correct ABP, correct ASP, correct ASI, correct EDI, correct. Cool. That's it. That's everything that needs to be correct. So next up, instead of pushing the original bytes to the starting of our function, we need to put it at the bottom so it will get executed before we jump back. Here, copy original code. How do I do that? We need to do we overwrite at the end as well? Let's do this at the end. Because func should be unchanged. And what is the jump offset from target, no, from func to target? We take this and we put it down here as well. But of course it needs to go to the start of target, so what I'm gonna do... Oh, here we should take this. Whoops. That's not where I wanted to go. Take this as well. Copy original code, overwrite original code. Here's our fake data segment. And then I'm just gonna make a label void target start equals target, so we now know where the starting address of our shellcode is. Now copy original code. We copy into target, which is what we want actually, because we are now, target is now at the end, but when overwriting the original shellcode we now need to jump offset static, no, not static cast. We can use 2wow64 and we say address relative to target start function. So now we should jump to the start of the shellcode. Actually, we might need to decrease this by 5. We might be 5 bytes off because the instruction pointer is pointing to the next instruction and the jump is relative to the instruction pointer, so it accounts for the current instruction's length, which we then need to subtract, and it's minus 5. No. Minus stub size 32, which is 5, it's just more clear that way. Oh, I need to stop the driver first. Oops. Shoot. Wait, what does it want from me? Oh. Don't need this anymore. Why is it complaining? Excuse me. Oh, Convert size t to uint pointer. Oh, because this is a size t and not a pointer. Right? Yes, it's a size t. And this... doesn't make sense. Cool, that's great. Static cast uint32, we just cast the u size t I mean, to a uint32. Okay, this works. Start the driver. Yeah, that's not correct. It's very much wrong. We are 2 bytes off. No. We are... This is very confusing. 1, 2, 3, 4, 5, 6, 7. We are 1 byte off. 19. This should be a 20. Why are we 1 byte off? Are we actually 2 bytes off? Hold on. Because there's a 2 at the end, and it should be a 0. One moment. 50 is the first one. Huh. Okay. Let me just think this over. Copy original code. That's fine. Overwrite original code. We are writing 1 byte and then 4 bytes for the address. And the address is target start minus func minus the stub size, which is 5. Do we not need to do this? That would confuse me very much. Wait. Oh, I didn't start it. Nope. This is 2 bytes too far. So we need to subtract 2 bytes. We need to jump to 1C. We are currently jumping to 1E. Yeah, that's 2 bytes off in the other direction this time. What is going on? How do we subtract 5 and then be off by 2? Either way. Where does the 2 come from? What happens if we just say plus? Let's just do +5 for the fun of it. No, we need to stop it first. Then we can build, and then we can start. Yeah, now it's just completely fucked. Now what I actually was wondering is 23. And we need to jump to 21. No, we don't. I'm just bad at math. Have we been off by 5 this whole time? Am I casting? I should not be casting to unsigned integers. Nope. Where are we? Wait. Oh. We didn't start the driver. Okay. So we are still 2 bytes off. No, 1 byte. We need to do +1. So -4. And if this works, I'm gonna be hella confused. I'm gonna have to figure out why this works. Because it makes 0 sense. Or maybe I'm just an idiot. I think it just worked. 1, 2, 3, 4, 5, 6, 7. Yep. Why does this work? What? Why? Are we modifying func anytime before this? Just copy the original code. No, we are not. and then we write, oh my god, I'm such an idiot. Oh, of course. I understand. So we are increasing function by 1 here. And then we calculate the distance between function and target function. Sounds of pain. Don't worry, the pain is over. I just figured it out. So we calculate the distance between target and function. And because we already increased function by 1, the distance will only be off by the 4 bytes we are adding here, which means we do size of int32, and now, well, now it works. What more do you want me to say? And after running the original code, we need to jump back. So another one of those fun relative jumps. So we do write bytes into target, and the bytes are going to be A9. And then we do write type int32 target static cast into an int32. We say relative to, this time the other way around, function, and not target start, but actually target. We say minus size of int32. Yeah, I'm not sure if this is going to work just because target is being increased over here. But I'm gonna try, and then we are just going to trial and error our way through, and then understand it in retrospective. Okay, this is the original code we have stolen, and then we jump back to, wait, 6.5. Holy shit, it just worked. Just first tried that shit. Hell yeah. That breakpoint is so annoying. Okay, I think the DLL is loaded, and we, oh shit, what just happened? Where do we come from? What's going on? What? Yes, no more breakpoints. It has been enough. Thank you very much. Oh, I think I understand. There's a dark mode. Yeah, I'm in a VM and I didn't bother to set anything up. But actually, you know you're making a good point. No, it's not. Here we go, theme dark. Yes, yes, thank you. It's kind of ugly though. I'm used to having like a super nice theme. Okay, I mean, to be fair, it's better than the light one. I think the problem is that this is a relative call that we are hijacking. Am I going to regret actually making correct detouring? I might very much regret this. Fuck. Yeah, maybe we need to do it the stupid way, where I just write a shellcode that will undo the detouring. But I've done enough for now. Gonna go for a bit. Maybe I'll be back later, but maybe not. We'll see. Might just do some chill stuff today. Hope you have a nice Saturday. And just gonna say goodbye for now.